Hey guys, this is the HackerNoon podcast, and today we have a special guest with us. Her name is Monica Quaintance. She has been heading the research and networks division at this blockchain company called Kadena. She is also a former senior data engineer at Rent the Runway. She has been a former quantitative analytics engineer at the Securities and Exchange Commission of the US. She also has experience in securitization and restructuring of commercial real estate assets in the investment banking group. And she has a double BA degrees in statistics and probability, as well as one from economics from the Columbia University. And she is championing the cause of pro diversity as a co founder at Universal Consensus. Along with her, I also have Lisa Tan, who will be joining me as a co host. She is the founder and lead economist at Economics Design, which is a research focused consultancy for digital ecosystems. She also has a weekly podcast on the economics of token ecosystems, online courses, and has educated regulators and companies across the world. Thank you both of you for being here.
Hello.
So, Monica, tell us.
Hello.
Yeah. Hey, Lisa. So, tell us a little bit about yourself, Monica. Like, how did you get started in the at the SEC? Like, how does somebody apply for your job?
Interesting. At the SEC, the way that at least I ended up with the job is Will and I knew each other from college. We were college friends, and Will was working in this totally random, tiny little group inside of the New York City SEC branch that basically what they do is develop highly specialized software to try to combat various forms of trading fraud. So somebody has to, when they subpoena the trade blotter for an organization, a bank, somebody has to actually take that trade blotter and then process the data, looking for any number of different types of trading that's illegal, like wash trading, where you wash in one account to another account in your same organization in order to make it look like the price is changing. Anyway, all kinds of different ways to commit trading fraud, and somebody has to make the software so that the SEC can try and catch it. And so Will called me up and said, hey, we have an opening in our group for somebody who likes programming system stuff and understands economics and has a background in banking. I was like, well, okay, great, let's do it. So I remember that those were some of the most grueling but also interesting interviews I've ever done. Just like totally spanned the gamut of talking about like probability theory in Bridge, the card game, to how does Python store different variables under the hood, and how does the memory management system work, and how does it interact with the C compiler, and just like basically everything. And it was awesome. But unfortunately, when I got there, they then went through a restructuring of the group. So both Will and I left like 3-4 months after I started. It was a totally wild ride, but got to see some really interesting things, and there are a lot of really brilliant people working for that group. It's cool.
Definitely.
Yeah.
And like, were there any like psychometric questions as well? Like, we had John McAfee with us that other day, and he was like, he worked for the NSA, and they had all of those weird questions for him, like, did you cheat on your wife? Did you gamble? Did you like steal from somebody? And he answered yes to all of those questions, and they gave him the job. They were like, this guy is not afraid of anybody.
Amazing.
So we would like give him the job. How about you? Like, what was your questions like on that side of things?
They were like a totally normal, although albeit an extensive background check. And they're like, have you ever lived in a country, blah, 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 where you might have been radicalized by like some faction of something?
Wow.
Have you ever, like, where are all the places you lived? Where are all the places you've ever traveled within the last like 10 years? So I had to like get out my calendar and be like, okay, 5 years ago in May, where did I go on vacation? Like, but besides just being an extensive background check, there's really nothing that exciting.
Uh-huh. Got it. And how did you like get introduced to the blockchain side of things, and how did you end up becoming the head of networks and research at
Yeah.
a blockchain company, Kadena?
So this is Will's fault again.
Okay.
You're sensing a theme of us dragging each other into trouble.
Thank you, Will.
Yes. Will, when I left the SEC, I went to rent the Runway and eventually rebuilt their back-end data storage system for where they
Wow.
keep information. And people don't think about it, but Rent the Runway, which for those of you who don't know, because you are not a woman who lives in a high-density metropolitan area, rents clothing to women, and it's high-end clothing. It's
Mm-hmm.
your nice blouses and jackets and interesting purses and statement pieces, and so that you pay a monthly subscription, and then you can have as many swaps of stuff as you want.
Mm-hmm.
And so they are North America's largest dry cleaning facility,
Mm-hmm.
and an incredible logistics business that tracks all of this data for all of these items of clothing. And
Mm-hmm.
they have warehouses where everything is moved on these racks and like shuttling around automatically. It's so crazy. It's super cool.
Mm-hmm.
Anyway, after I left the SEC, I went to go do data there. And then
Mm-hmm.
Will went to JP Morgan to the Research Institute, where they have a group inside JP Morgan that basically vets technology for people that are trying to sell to JP Morgan. They're like, use our
Mm-hmm.
software. And JP Morgan's like, go look at their software, figure out what it does. So the research group, in exchange for doing some vetting, also gets to work on experimental software projects.
Mm-hmm.
So they had a lot of people coming to JP Morgan saying like, hey, use our blockchain. JP Morgan was like, what's a blockchain? So Stuart and Will started researching all these different blockchain solutions for the bank. Like, hey, everybody's talking about this Ethereum thing. Like, should we use this at the bank? Like, people are clamoring that this is like the future of currency. Like, we should know what the future of currency is.
Yeah.
And they looked at Ethereum and they were like, programmable money. Like, these
Mm-hmm.
contracts aren't safe. The network doesn't scale. Like, nobody can understand Solidity. It's confusing and full of safety holes. Like, it's terrifying to send your money on a blockchain. Even for people who've been doing it for years, every
Mm-hmm.
time I check the SIG like 16 times. And then when I push the button, I'm like praying, like, please don't let me have messed this up, because there's no insurance. It's irreversible. You don't know who you're sending to. Like, there's no verifiable identity on your counterparty. So we're like, Will's like, we can do better. We can do better. So Will and Stu left the bank.
Uh-huh.
And Will called me and he's like, here's the deal. We're making a public blockchain. We're making a cryptocurrency. Do
Mm-hmm.
you want to come? We need somebody
Mm-hmm.
who understands the movement of distributed data systems, economics, and can talk to non-engineering people about engineering things. I was like, okay. I've never made a
How many
blockchain
people in
before,
the world
but
can do
let's do
that?
it. I don't know. Maybe just me. I mean, there's some other extremely brilliant people out there at blockchain projects, like, Zaki Manian at Cosmos and Goon at Avalanche and Alex Gidanov at Near. They're like just super brilliant. I feel really privileged, honestly, that I get to interact with them and like sit down with them at the table kind of as peers, although, they're all way more successful than, at least in terms of size of the market of all their projects right now. But I think we can hold our own. I think we're going to make it. I think we're still like the little blockchain project that could in some ways, even though we have hit a bunch of major milestones. And it's a heady feeling to know that those people consider us to be peers. It's good.
Mm-hmm.
Yeah.
Mm-hmm. It's always good to like have more competition in this space. Like yes, Ethereum had their early success, and people forget that they had their DAO hacks over there as well, which led to the splitting of the entire like Ethereum blockchain.
Yeah, I
Like
mean, we've all had growing pains and we all struggle. And in some ways, like the public spotlight in which people start talking about your flaws is just as important to the growth of a project as people talking about your successes, because people only care enough to criticize you if you're potentially worth something. Like you
mm-hmm.
don't become a target until
Yeah.
people actually care.
Right.
So the fact that people are starting to come around and like try and poke holes in what we're working on and try and you know tell people, oh, those people blah blah blah, that they say that it works like this, but it doesn't really works like this. Like that just means to me that we're succeeding in what we're trying to do.
Mm-hmm.
And
No,
what we're trying to
definitely.
do is give people an actual programmable blockchain that they feel
Mm-hmm.
safe using, that they feel comfortable using.
Mm-hmm. That's right. And I guess like Lisa has been in this like blockchain world for a long time, and both of us have like seen companies who would promote themselves as the unhackable blockchain, the blockchain that cannot be hacked. And the general consensus among technologists is that if you give anything enough computing power, it can be hacked. Like it's just a function of time and resources.
I mean, the whole idea of unhackable just in general is counter to the way that systems work, because
Yeah.
any system that's made for people to use and access means that it potentially has vulnerabilities. Because I mean, you can make a system that runs by itself forever that nobody can access, great, like who cares?
Mm-hmm.
Or you can make something that people can actually try and use, but that'll always leave you open to some kind of vulnerability, whether it's trying to exploit the mechanisms of participation. For us, it's mining. For other projects, it's staking.
Mm-hmm.
And always going to be people that try to socially manipulate the people on the platform. Like this just goes back to the idea of like, people only try to hack your blockchain when it's worth
Mm-hmm.
something.
Mm-hmm.
So like your blockchain exists because people want to use it. People want to use it. People are going to try to hack it. So
Right.
and all you can do is, in my mind, from a usability perspective, give the users as many tools as possible in order to try to let them control their experience, rather than making
Mm-hmm.
design choices like kind of like Ethereum did, where they're like, okay, I'm not sure whether this was a conscious choice or not, but they're like, code is law. That means that
Right.
when you release a smart contract, what you get in the wild is what you submitted. But people make mistakes. People make mistakes all the time,
Right.
which leaves you open to security vulnerabilities. And so we'd rather give people tools to actually be able to swim in an environment where there is a lot of uncertainty. You
Mm-hmm.
can make built-in escrow contracts. You can have built-in multi-sig transactions that require multiple people to sign a transaction. Like all of
Mm-hmm.
that totally native to the platform and built into our idea of what safety and security looks like.
Mm-hmm.
I just sorry, I just went off on that one. I got inspired.
It's always like nice to hear people who know stuff talking. So no questions there.
Okay,
It's
good,
always like nice to
cool.
have people like that. Yeah.
Well, I feel like
And
I've lived the last
yeah.
20 years doing blockchain, although it's only been 3. So we
Mm-hmm.
can have a nice, as deep as you want to go. As deep as you want to go.
Perfect. So at this moment, I'd like to let Lisa take over and discuss how is your solution different from Ethereum from a tokenomics perspective, from an economics perspective. How do you incentivize users? How different is it from the hundreds others that we have seen? And I guess like Lisa has more experience on these, so I
Yeah.
will like let her take the floor.
Yeah. So Monica, do you want to start introducing what Kadena is about and how tokens are being used, and talk a little bit more about Kadena?
Yeah, let's do it. All right, so Kadena's purpose, when you go back to remember the genesis of the company and the blockchain, that what the original purpose of this was we want something that's straightforward and safe and simple, that actually provides the kind of services that Ethereum said it was going to provide. You know, truly be Web 3.0 programmable money, but also be as safe as possible. And so when we think about the structure of a blockchain and how we fundamentally wanted it to work, we wanted something that was essentially Bitcoin with scaling and smart contracts on top. So we didn't want to vary, to change too much from what we consider to be a system that actually works, which is proof of work. The problem, at least in my mind, that most people have with proof of work is it doesn't scale. If you could have Nakamoto consensus and you could push through as many transactions as you wanted, if it scaled infinitely, nobody would be making all of these complaints about proof of work, like, oh, you know, it's not environmentally conscious, or like, well, you know, you have to invest in a bunch of hardware. The great thing about investing in hardware is that anybody can go out and buy a mining rig. Not anybody can go back in time, like make sure that you were among one of the first people to ever, you know, bake a block of Tezos. Like that's just not possible. So we think proof of work and Nakamoto consensus just works. Like it's math. Are you the first person to solve the math puzzle? Great. You can participate in this network. And we think that that is, I think it's incredible that we went through a world in which essentially you have to know who your counterparties are in some kind of trusted setup, to anybody, literally anywhere in the world. Grandma in Krakow with a computer in her closet could theoretically mine a block of Bitcoin. Like anybody, anywhere in the world. And so we took proof of work and we went, okay, if you have 1 Bitcoin, you can have 1 block. What if you had 2 Bitcoin? You could have 2 blocks. And then this idea of, okay, but if you have 2 separate blockchains, how can they communicate with each other? So the way Chainweb works, that's our consensus protocol, is 1 block, if you only have 2 chains, contains not only its own proof, but the proof from its sister chain. So then you have 2 proofs embedded in 1 block, which keeps the network in sync with each other, because if the next block on, let's call them chain 1 and chain 2, the next block on chain 1 contains a proof in chain 2, and then the node then tries to mine a block in chain 2, they're like, wait a minute, this proof doesn't match the one that's in chain 1, that doesn't make any sense, and it will discard it. So that's how we do fork management. But the great thing about Chainweb is the more chains you add, it doesn't necessarily scale linearly in terms of the number of connections you have to add. So we are on a 10-chain graph right now, which requires 3 connections to other blocks at the same time. So your own proof and then 2 other proofs. But soon we are moving to 20 chains. That's actually our major software lift right now, is migrating the network from 10 chains to 20 chains, which requires a dynamic difficulty adjustment function so that each chain knows exactly how hard it should be to mine the block given the distribution of power in the network. It's like totally crazy stuff. The formulas are really cool. And so more blocks means more transactions, means bigger, more scalable network without an increase in fees. And so we figured out how to scale proof of work, so we decided not to abandon proof of work. Like, proof of work is cool, we can just mine more blocks. So that's the mechanism for how the system works. And then on top of that, we have a smart contract layer that functions, we like to say that it is like an upgraded version of what smart contracts could be. Because everything, even the coin contract for the network itself, is a smart contract. And then those smart contracts, because of the choices we made in the language design, you can actually formally verify every contract that every user writes. It's built into our wallet, actually. You can just like load our wallet up on your computer, type in your contract, and put parameters around it, and then it will check whether those parameters are true. So that's cool. Okay, so the design of the network is we're proof of work, totally stock proof of work. It just, you can get paid on 10 chains at a time rather than 1 chain at a time. And so we run with mining, like Bitcoin style, classic Ethereum style mining, and miners get compensated for the transactions that they process, and they get compensated for mining new blocks by getting rewarded with new tokens. It's not that complicated. It's not that excited.
It sounds amazing. So before we go deeper into understanding a lot more details, I think you've covered a lot of details. And if I could summarize how Cardano works, it's like a tree with a lot of different branches. And so the main tree trunk is summarizing all the different transactions that's going on in each branch. And the branches can just kind of branch out.
Branch. And so that to me is a little too hub and spoke. The idea that there's this like central trunk with leaves off of it. Mm-hmm. It's more like there are 5 trees all growing in an orchard, and their branches like cross each other as they are growing. Each tree is independent of each other. They each have their own ledger. They each have their own system of accounts, and each blockchain could progress on its own without the others around it. And then they just like send out little bursts of information to each other. Actually, the way that actual tree networks do by entangling their roots, but let's not go there.
And pollination, right?
Right, yeah. So it's more like you have 5 independent trees all growing at the same time. Right now we have 10 trees. We seem to have 20 trees. We just extend the metaphor to the whole forest.
So whatever transaction is going on my tree can also be interacting with whatever transaction that's going on your tree, even we're 2 different trees from 2 different places.
So the way we do that is with a cross-chain transaction. A cross-chain transaction, so if I do a transaction within the same tree, you can just do it in a single action, which is, I send something. When I would be sending to another chain, the way we do it is I say, okay, these tokens are going to go exist on chain 3 now. Please send them over there. And what happens is out into the network, a block with that proof in it that says coins from chain 0 can only be redeemed on chain 2. And then you on chain 2 see this proof come in. The coins have been burned on my chain, so that they're gone. The actual total number of tokens on chain 0 briefly drops. And then the total number of tokens on chain 2, you get that receipt, you consume the receipt, and from it, you rebirth these tokens onto your own chain. So the number of tokens on each chain doesn't actually need to remain constant. It's a totally free-flowing system, and it's a simple payment verification to go from chain 0 to chain 2. And if at any point during the middle, your transaction gets, like something happens, like the block that you were in gets dropped and, you end up with another fork. If you're before the transaction ever happened, you don't care. If you're in the middle, the receipt hasn't been consumed yet, so it's still out there floating. And then if you're at the back end, like you've completed your transaction, you don't care.
So in the middle of the time before, once the token is being out there to be approved for transaction, and before the other person actually approves it, that ownership or that property, the rights of this token is still belonging to whoever that holds the receipt of the original token.
Yes.
Oh, that will really reduce the stress that you're talking about just now when you're checking and you don't know when your tokens are being verified.
Yeah. The whole system is designed on trying to be as foolproof as possible. And trust me, it doesn't mean that you still can't mess up doing transactions. Like in the very beginning when we were running on testnet and we were firing transactions around to each other, I would screw things up all the time. I would put the wrong key guard when I was making a new account, so then I wouldn't be able to actually do anything with it because I didn't have permissions for my account. Or I'd, give them keys any access instead of keys all access on my access permissions. And then I'd be able to get into my account, but I wouldn't be able to mess around with it. It's just I've done it all. I've made all the mistakes, but this is how we build a strong system: is you mess it up enough times where you're okay, we really think that we've messed it up in so many ways, and then you pay people to come in and try and mess it up even more, and they're like, no, we can't mess it up either. So it's we're reasonably confident now that we've given people the tools to be able to protect themselves.
Sounds really great. That's how you build a strong system. You have to break it down and make sure that it cannot be break down any further.
Yes.
You mentioned that you're going to use tokens as a way to incentivize miners to be approving all these transactions because you're using proof of work. For a new tree to be grown, so for a new network to be part of the whole entire ecosystem, do they have to, is that token related to a new tree being planted?
Got it. So the structure of the network is fixed. Like it doesn't change. These are the 5 chains. These are how they talk to each other. It's defined in the network parameters that were created when we originally had network genesis. So it's not like a system in which you can like spin up a new validator that can talk to the other validators. Like there's no user involvement at all in the structure of the network. It's when you sign on, you see messages coming into your queue as a miner into the mempool that have as many different feeds as you want to subscribe to chains 0 through 9. And so if you're subscribing to the chain 0 message feed, you get transactions from there. You can bundle them into a block and you can mine that block. And you can subscribe to as many feeds as you want, 0 to 9. And so that the network itself is fixed in terms of its structure, and the blocks you can see as a miner. That's why our upgrade from a 10 chain to a 20 chain network is going to be such an awesome achievement when we do it at the end of the summer, because this is us proving that we can migrate a network from a smaller size to a larger size, which means that in the future we can continue to fork out the network to larger configurations. It's important that the network structure is fixed because it means that we're going to like dip into a little graph theory here, that when you have your graph, that a fully connected graph would be where every node talks to every other node. That's too many messages. That scales like the n over n minus 2, like, you know, it scales extremely quickly. Nodes connected to all the other nodes. And so when we had the idea for Chainweb, it's really important to be able to have full propagation of information with the minimum amount of connectedness, but also the minimum diameter. Diameter being the number of hops you have to take for you to be able to talk to any other chain. So like, if I only want us to have, if we're a 10 chain, we don't want each node to talk to each other node, but instead I could send a message as chain 0 to you as chain 1, and you could forward it on to, you know, your friend on chain 3. And that message propagation allows us to have a reduced number of messages on the network, which means it's not totally crazy to have all these things talking to each other.
By that logic, it's also possible to have one of the chains to be completely private, where my connections and my messages will not be able to talk to another?
Can't have that happen, because the only way that blocks get made on the network is if each chain, so if you're in chain 0 and you require proofs from chain 0, 1, and 2, then if you're not getting blocks from 2 for some reason, like, you know, somebody's attempted to buy up all the hash power on chain 2, then you just hop over and you start mining chain 2. Like if you saw that the Bitcoin network was slow and that blocks weren't getting produced, you're like, woo, cheapest block I've ever mined. Like, I'm gonna go hop over there. So this idea that you can censor one of the chains in Chainweb just isn't possible, because if you see a chain that isn't producing blocks, you're like, cheap, I'm gonna make it myself.
And you mentioned that for each block to be validated, they need 3 other chains' information to be validating a block.
So I don't try not to use the word validating,
okay,
because it tends to get people confused and think about we're talking about a staking system, because we're not a staking system. It's, you have to proof check proofs from your sister chains before you can mine the block. Like similar to the way that when you get a block in Bitcoin and people are like, hey, this is the new leader block, and you grab it, the first thing you do is you validate the hash to make sure that it's true. And then on top of that, you then start building your next block. You just perform that first step, make sure that this is true, with 2 other proofs as well from sister blocks, because you're maintaining the history for not only your own chain but also 2 other chains. It sort of mixes this idea of sharding in terms of, you know, that you're covering more than just your own share of the transaction pool in order to have some overlap. This gesture looks really funny on camera. But rather than it being from a validation standpoint, you're actually just checking the hashes of blocks on other chains. And then you include them in your next block, and then you then proceed to the next one. And this means that sort of like a three-legged race, you're tying the blockchains to each other so they can't ever get further ahead because they have to wait for their sister chain's proof so you can't have like network lag and like if one chain is just for some reason not producing blocks, the whole network will actually have to slow down to catch up. But miners should be hopping over. Actually, our mining software does this automatically, reallocates hash power to whatever chain is the slowest because that's the most potentially economically beneficial for miners.
So your system automatically allocates the distribution of power so that everything will be mined at the same rate.
Well, it's not like it's not like some kind of malicious automatic reallocation. And miners could build their own mining software to allocate however they want. Like maybe they only want to mine chain 0 for some reason, and then they'll have to listen to a message queue from a pool in order to get validation on that the information that they're receiving from on their blocks are correct because they're not validating those other chains themselves. Like totally an option. But our software does switching because it's trying to make the miner the most money. And so whatever chain is this, like we can imagine it like some kind of membrane where it's a pool of hash power. And if any chain is like lower than the others, it like pulls on the membrane and like pools the hash power down onto whichever chain is the lowest until it evens back out again.
Sounds like time travel to me.
Sounds
like time travel to me.
It's basically time travel.
Yeah. Like I have been like listening to you guys for the past 5 years. I'm like, yeah, something gets created at this end while simultaneously like getting destroyed at the other end. I read that in some sci-fi novel.
Yep.
Very nice to hear that. Like I can make my own analogies. Yeah.
Yeah, that's like the Prestige. The Jonathan
exactly
Nolan
like
movie.
Prestige, yeah.
Yeah, where he's spoiler alert for the Prestige if anybody hasn't seen it. One of the magicians appears to be teleporting, but really he's just copying himself and then murdering his old body every time. But that's not the order that we do it in, because that wouldn't be safe for simple payment verification. It would result in double token. And you would have to trust that the first party would actually kill themselves. We actually do. We kill them first, and then we resuscitate them. I got dark fast.
Yeah.
Sorry.
It's actually very helpful that both of you can speak to the rest of the world. I mean, people like me who don't understand these terms, because you guys need to break it down. And analogies are the best ways to do that. We could all talk about Byzantine fault tolerance, tokenomics, and the stuff that you guys have been talking, right? It would never register to the common people unless you guys can break it down. So, like, thank you guys, like, both of you for these wonderful analogies. Like, okay, we had to bring up Prestige and Hugh Jackman had to die, but it's all right.
Right. I got called out for my analogies on a podcast a couple of weeks ago. We were talking about Oracle integration because we have a partnership with Chainlink, and our goal is to bring in data sources to our blockchain so that when people program smart contracts, they can get like, oh, a spot price feed for Ethereum. Like, let me know how much Ethereum is automatically whenever I'm instantiating this contract. And I was like, yeah, it's like you're sitting in a dark room and your brain has no stimuli, but then you turn on the lights and you turn on the radio and suddenly you're receiving information. And people are like, so Monica thinks like Kadena's like a brain, and Chainlink are like, right, yeah, it's like a brain.
You mentioned that code is law. It's not really a philosophy that you guys bring on board. So what would be your governance mechanism? Because another thing about oracles and having information from all these decentralized sources is that what if they're manipulated, and how do we know which is the most definite answer to how the smart contract should integrate the information so as to approve or to prove the check?
There are multiple, you touched on multiple different things in your question, so I'm going to break them out into pieces. one of them is this idea of code is law, which is that when you ship your smart contract, it's immutable. And then you also brought up a separate issue, which is how do you determine whether the oracle you're using is trustworthy? I think those are actually like two questions.
Okay.
And so the first one, like, I guess if our motto isn't code is law, it's, you know, developers make mistakes. People are human, and we think that, or maybe it's that code is change, because when you think about software, like, you're literally always updating everything all the time. Code that is static is code that dies. It's code that no longer works and performs the function as intended, because we as humans are mutable, and our desires and business decisions and the things we need and our goals, like, are always changing, and code should serve that. Code should be an extension of your will, not something that manifests the will that you had 6 months ago when, you know, the API that you were hitting was giving you this, and what you really wanted to do was this. Like, what you should do is, like, every time as developers, what we're doing is we're building a castle out of sand on the beach. And meanwhile, like, the wind is blowing and the waves are coming in, and it's like scooping out the bottom of your sand castle every time they're like, we're going to update the Haskell compiler. And we're like, no, don't do it. And like, oh, you have to update your operating system. Like it's just constantly trying to like shovel new sand down into the hole. So the idea that when you deploy a contract, you shouldn't be able to change it is like, well, that's totally useless. You can never, even your business decisions change. And smart contracts code looks, it's not code like system code. It's code that should reflect what you're trying to do and why. It is business logic codified and given to a machine and told to execute. So the whole idea behind Pact, our smart contract language, is, and the way that our system works in general, we have this like radical idea of you should be able to name your accounts different than the public key on the accounts. So you can like change the name if you want, which was like a totally radical thing that Ethereum didn't do. And you should be able to name your smart contracts, and then if you don't want to use that one anymore, you can just change the reference to a new name. So you'd be like, contract A. You're like, contract A, version 2. So that you can actually change what's going on. So you can see the previous version of the contract. It's always going to exist on the blockchain, but you just might not want to use it anymore. And that's just like, oh my God, you can rename something? Like, totally mind-blowing. But it's, so that's our whole idea about code is law, is that, you know, code is law, it just means code is dead. It's not going to happen. So that's the first idea. Do you have thoughts on that?
Like, I personally, like, I am not a programmer, but I work with a lot of programmers, and none of them say that code is law, because the literal definition of code is law is code is God, and code is not God. You need to have room for evolution everywhere, right? There has to be a mechanism by which something can be evolved. We have all had constitutions, like Singapore has a constitution, the US has one, India has one, but we keep on amending it, right? So similarly, like, there has to be a mechanism, the way that I see it in the programming world as well. I had a few questions about your programming language, Pact.
Sure.
Yeah. So I read somewhere that it has the same like encryption mechanisms, like, which is symmetric encryption, similar to Signal and WhatsApp. And again, like, I don't know much, but what I like read somewhere that Signal security and WhatsApp security is not as good as it should be. So have you guys like improved upon it in certain ways, or like how do you like guys take care of security and encryption within your services and within your programming language?
Mm-hmm. So we use the same signature model that pretty much everybody, I think, who knows what they're doing on signatures is ED25519, which is just a particular elliptic curve that you can use to sign your transactions.
Right.
And I think that it's really important to not mess around with cryptographic algorithms.
Mm-hmm.
Like, I'm not a cryptographer, although I really like cryptographers, which is why I work with the International Financial Cryptography Association. But
Mm-hmm.
like, they're really awesome, and they spend a lot of time thinking about like, what is the shape of this curve, and what does it mean for numbers to translate on this curve? And like, they're way smarter than me, and I think it's awesome. So our fundamental theory was, don't mess with what we know works. So we
Right.
use the same signature encryption scheme that like basically everybody else uses. And our hashing algorithm is a well-known and well-tested algorithm. We use Blake 2S, and so it's just not. We didn't mess around with any of that stuff. It's way above my pay grade to like try to deal with cryptographic hashing schemes.
But like, yeah, let me like tell you, I spoke to Charles Hoskinson, the guy who founded the Kadena blockchain. So he is a cryptographer, and I asked him the same question, like how surely do you believe that your cryptography is going to be secure? And he laughed at my question. He was like, these questions were answered in the 1980s. You don't need to
Yeah.
worry about it.
Yeah, that's why you don't mess with them.
Yeah, you don't have to mess with it.
We figured that one. Math says math works.
Yeah.
We're out. So this is one of, we don't always agree, Charles Hodgkinson and me, but
Mm-hmm.
I think one thing I can agree with him on is don't mess with good cryptography.
Right.
Yeah. Also, they also, at least for some period of time, were using Haskell as their the basis for their blockchain, which made me like feel a little heart pulse of solidarity because we use it too.
It's his favorite programming language, and like he is the founder of the company. It
Right?
had to be Haskell.
Yeah, it had to. We get to do some cool things because of Haskell.
Yeah.
Because specifically regarding Pact, the programming language, Pact is written in Haskell, but you don't have to know any Haskell to write Pact. It's like the way that Python is written in C, but you don't have to know any C to write Python. Like it's just from where did you germinate your programming language? But it means that when we were trying to make the formal verification system, it made it relatively easy to unpack the definitions of everything that you've defined. What does it mean? And reduce that into something that could actually be parsed in math. Thumbs up for that.
Got it. And I also like read somewhere that Pact supports entirely new business models and on-chain services. Like, what could be like some of these like new business models that can be supported by Pact but not by some other languages? Like, let's say Solidity. We have Viper, if you have heard of it, and then there's this new one which is built by the people at Blockstack. They built this language called Clarity.
So the thing about Pact that's really awesome is it is so expressive while simultaneously being compact, so that you can do a lot of things with it, but it doesn't necessarily make things overly complicated. Like, it doesn't let people do things that are stupid. And there's a certain amount of like where we were like, we've decided how you're going to use this programming language. And how you're going to use this programming language is specifically designed for how you want to use blockchain contracts. There's no like, hey, we actually took this like JavaScript thing and we decided to like shave some bits off of it and now you can use it to write smart contracts. Like, this language is purpose built for smart contracts, which means it has a bunch of stuff built into it automatically that you would just assume exist if you were designing something for smart contracts. Like, you can have native multisig, and every time that you define something, rather than signing it with a key, you actually sign it with a key set. And you can have a key set that's just one key, or you have a key set that's 3 keys, or you have a key set that's choose 2 of 5, or you can have a key set that's my key works all the time, but Lisa's key only works on Saturdays. Like, you can do basically whatever you want with your key set. And so that kind of intimate nature of this has been wedded so deeply with smart contracts means that you all of these security where you're like, I can't use a native Ethereum smart contract for multisig, but like somebody else built this thing that like kind of does what I want it to do, but you have to trust their code and hope it's not broken. Like, no, multisig just works. You don't have to worry about it. That's why Pact has this potential to do so many cool things. Like, for example, we just released a test application on mainnet that is the first ever gas station, which is what we call when you, as an app developer, you can create an app and you can set a smart contract out there that has a pot of tokens in it that when new users come to your application and they want to sign up and create an account, that transaction where they're like, hi, my name is Monica and I would like to make an account, and then it goes to the app, which sends it to the blockchain, it can draw the tokens from the smart contract that you have put out there to serve as a gas station, so that I, as a new user, don't have to buy tokens in order to sign up for your app. I don't have to have a wallet in order to sign up for an app. In fact, you can do all of it for me and you can pay for it. So it's finally having this Web3 type of experience where you're actually using a blockchain application that has all of the usability features of a Web 2, just like, I want to go over to Google and type in my blah, 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 and like a centralized corporation takes care of the vetting of the whatever, and they run the servers, so they pay for the gas. Like, I, as an app developer, can finally give my users an experience that they recognize, that's familiar to them, which is one of the biggest problems of getting people to use a blockchain application, is first you have to understand crypto, which is just like so impenetrable and scary. And people are like, I don't understand how cryptography works. Like, I'm never going to own a Bitcoin. You can just skim over all of that. And as a developer, you can just put a layer on top of it for the user that's like, it's cool, just sign up. We'll make your account. We'll make your wallet. We'll make sure that that the guard on your wallet corresponds to your key and not to our key. Like, totally fine. And so we've really started building out these features to make it easy to draw people in and say, you know, the products that you can make here can be safe. The app that you can make here, you know that the network is going to have enough volume for you. You know the gas fees are going to stay low. You know that when you write in this programming language, you're going to be able to formally verify your contracts. You're going to be able to check it. You're going to be able to integrate natively with a private blockchain if you need to also have transactions that are stored on a private blockchain, because our not only do we have an integration with Tendermint, so you can actually write things that are compatible with the Cosmos network.
Right.
We've just announced that we are doing a partnership with Polkadot, where you can also, right now we have a request for comment from the Polkadot and Kadena communities out there. Do they want us to run a full packed service parachain on Polkadot, which will give you actually full access to the APIs as well as the packed core development? Or do you want something that's more like a packed core, but that could be deployed on any WASM type system anywhere? So we're like, how do you want to be able to interact with Polkadot? Like, tell us now. And or you could use our own private blockchain, which is called Kuro. So you can, like, you have a one-stop development suite in our app Chainweaver where you're like, this is my wallet, this is my development toolkit, public blockchain, private blockchain, testnet blockchain, like just boop, 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 boop. So we're trying to give people an experience of something that they actually, not just like, I'm going to tinker around with blockchain, but like, I have an idea for a company that's going to exist on a blockchain. It's going to allow people to, I don't know, safely and securely rent apartments in cities they don't know by doing integrated background check and escrow, so that you can hold somebody's money in an account where they can see and trust it, and, you know, be able to have all of your interactions just inside this one application. Like, great. Sounds good.
Sounds like
actually
a one-stop
make
shop
a business application. Yeah, that's the goal. Is we want people to feel like this is the place where they can go to actually build the cool thing that they're dreaming of.
So going back to it, you mentioned that as a developer, you can just create a pot of tokens to facilitate all the first interactions and transactions. Where is this token coming from? Is it minted out of thin air, or the developers have to put in money to be funding?
No, they have to put in money, and that's like, you know, if you were running on AWS, you would put a bunch of, like, earmark in your budget, like, okay, I'm going to have to run servers in order for my people to blah, blah, blah. In this case, you just take that money and you're like, all right, I'm going to put in the smart contract and it's going to pay for gas fees for my new users that want to onboard. And Kadena also has a developer program where if you're coming in and you want to make a test application, like we'll set up one of those pots for you and key it to your access so that you as a developer, like you'll only be able to burn tokens at a gas station. You won't be able to like trade them.
Right.
But you can then use those tokens to go in and try and build stuff, and then it'll just automatically pay your gas fees for you, like doop, doop, doop.
Got it. Let's take a step back and let's talk about a couple of terms that we hear in the realm of cryptocurrencies. What is the hardest word that you had to explain to your mom? Like for me, it was Byzantine fault tolerance. Like, what's yours?
So the embarrassing thing, or maybe not embarrassing, is that my mom is actually way cooler than I am, and like way tech savvy. She's the head of innovation for this like mega huge law firm, and so she's always sending me like, did you see that Deloitte has just announced that blockchain is imperative to its strategy for 2021? Like, have you reached out to Deloitte recently to see? I'm like, mom. She knows all about blockchain. She knows all about proof of work versus proof of stake. She has opinions on like all of these blockchain people. So I don't know, probably the hardest thing that I had to explain to my mom in the first place was, hey mom, I'm going to leave this sweet data engineering gig that I have with this company that I love, with my colleagues that I think are amazing, that's making bank and is probably going to IPO soon. And instead, I'm going to go make my own fake money and sell it to people on the internet. She was like, what?
Oh my God.
But turns out that people actually really want to be able to have a programmable money that they know that they can manipulate in a trustworthy way. So I think that the money that we've made is actually, people are actually really into it. And, you know, we launched on Bittrex, which was our first real exchange listing in June, and it's gone very well. We're very excited.
Congratulations.
Thanks. It feels like people are finally opening their eyes, really, that we've been here all along, that we've been here, you know, before the bubble, through the winter, through the whatever the heck 2020 is. And right. And we've, you know, every single major engineering milestone, we set a date, we hit our date. We set a date, we hit it. Like mainnet, like consensus protocol is coming out on October 30th, 2019. We hit our date. Like mainnet is going to come out for executing transactions on the final date in March. And you know what? We set our date and we hit our date. Like everything we've ever said we were going to ship, we shipped. Everything that we ever said we were going to ship has worked. We've been here the whole time. So it finally feels like people are paying attention to the fact that what we've made does what we've said it does. And it's exciting. It's an exciting time.
Congrats. That's a rare achievement, because a lot of times people don't really hit their deadlines and their end goals, their target dates.
I've heard so many rumors and so many horror stories of like, well, they decided to rewrite the whole thing in Rust, and we scrapped our entire work for the last 8 months. Or like, well, they've decided that they're actually laying everybody off and moving the office to Singapore, wherever that actually means they are. Who knows? Like, and we're just like heads down, just doing the thing, just writing our thing. And now it's finally really starting to pay off. We've got we integrated with Coinbase has this program called Rosetta, which is basically they're trying to make a standardized API for how exchanges interact with projects. So one of our major goals for the beginning of the summer was nail the Rosetta integration, like really, and provide them with feedback on their API on how to make it as tight as possible to serve our project, so that we are ready to roll when it comes to anybody that wants to integrate using Rosetta. We have, you know, a bunch of exciting things coming out now. It's like people want to use our stuff. People want partnerships. They want to be able to connect to the things that we've made, to be able to use our smart contract language. We've got, you know, tokenization of some hard physical assets coming due on our chain soon. And, you know, people are really responding to the things that we built, and it's it's an exciting time. It's a good time.
Awesome. That sounds really, really exciting. And as an ecosystem continues to grow, more transactions are being made, and I would assume that you're going to need more miners on board. So
Yeah.
what will be you mentioned your token distribution will be something similar to, the proof of work will be something similar to Bitcoin. Will your proof of work and the allocation and distribution of tokens will be related to the number of transactions that's available, or it's fixed at a specific parameters?
Yeah, so the mine out for tokens on the network is fixed, and it's been fixed since the very beginning. We actually mine out on a 120-year schedule, so miners are going to get paid for mining blocks for a very, 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 very long time. Like, may we all be around in 120 years to figure out what's going on with block rewards. But until then, for the next 10 years, the tokens are generated. Let me see. I have to do this backwards in the camera so it looks right. It goes up over time if time is going that way, and then it starts to level off over time. So there are 200 million tokens that are available. I'm going to just like try to bump these off on the top of my head. 200 million tokens that are available at the end of year 3, and there are 400 million tokens that are available at the end of year 5. By available, I just mean like have either been mined or are out of lockup. And so like, for example, at the end of year 1, there are going to be like 65-ish million tokens, and 30 million of those go to miners. And then over time, that's the proportion that goes to miners gets higher and higher and higher over time. It's 70% of the entire network is mined, and 30% of the network was pre-mine, and most of those we are locked up for platform development over an actually extremely long time lock schedule. So the platform share is designed for long-term investment in the platform.
Got it.
I think
that's a
like
very, very brilliant model,
contributors
because one of the problems with Bitcoin is that.
Are you there, Lisa?
Yeah, Lisa.
Sorry, my internet's a bit unstable.
Happens.
It's okay. Yeah.
So, I was saying that this is a really brilliant model, because one of the flaws in Bitcoin, I would say, is that most of them you'll be rewarding in block rewards, and then it'll be transaction fees. But the problem is that once Bitcoin is seen as a store of value, then there will be less transactions going on the network, and less miners are incentivized to be wanting to mine.
Yeah. So
you're solving the problem by not allowing the users to be incentivizing the miners, but the system.
Yeah. So we still have
but the system
fees,
incentivizes that.
And transaction fees are, you still pay miners in gas in order to execute your transactions. That's the reason that the token exists on the network, but we don't expect it to be the lion's share of a miner's compensation. And because of that, that's one of the reasons that we can keep gas fees on the platform quite low, so that people actually want to push transactions through. We're designed to be a computer, not to be a store of value system.
So for users buying these tokens off exchanges, why do you think they're buying the tokens for? Because it's not like a proof of stake mechanism where you can use the tokens and then be validating or to be approving of all these blocks. So why do you think people are purchasing these tokens?
Well, they could be developers interested in trying to use their tokens to develop an application, or they could be people who believe in the future of Kadena as a project. Like, we think that this is going to be around. We think that people are going to use it. We think that, because it's useful, people are going to think it has value.
Got it. Let's take a step back and try to taper this off, because it's been over an hour and it is a very weird time.
I haven't even noticed. I've been having so much fun.
Yeah. So it's evening for me, but it's I think 9 p.m. for Lisa and 9 a.m. for you. So we'd be tapering off with a couple of not very blockchain related questions. The first one of them would be that you are the co-founder of Universal Consensus, which is a pro-diversity in blockchain group. What are your thoughts around diversity And like obviously, like all of us know that technology is very non-diverse, right? How do you like make sure that you get things done correctly? Because all of you guys over there are very brilliant, very smart. How do you smart people tell the rest of us to fix this thing?
Yeah, I mean, it's a complicated issue, right? It's something that isn't just a problem in our industry, but I think there are multiple factors that, when combined, make it particularly acute in our industry.
Mm-hmm.
One of them is that you have to be pretty risk averse to be interested in crypto. Like, you have to be somebody who's like, yeah, this area is pretty basically totally unregulated. It has no protections and everything could be a scam.
Mm-hmm.
So you have to be somebody who's in a place of security in their life in terms of, economic potential and social potential. Like, you have to have a safety net to fall back on. You have to be wealthy
Mm-hmm.
enough to be like, all right, I'll just speculate with crypto for a few months. Like, that kind of baseline is easier for the more affluent, and that demographic of more affluent and privileged tends to skew, at least in the United States, towards white and towards male when it comes to being risk averse. Like, men tend to be, for, I don't know, reasons, testosterone, who knows? Let's not speculate like in terms of gender that way.
I
But
wouldn't like that. Yeah.
like like, men are more willing to gamble, women are more like, do we have a plan here? Like, what is going on? At least that's been my impression in life. And maybe this is because society pressures women to have children, and therefore, you have to know that you can be a provider, which means you're less likely to be like, all right, in my 30s, I'm going to just like totally skiv off from my nice, well-paying job that gives me benefits and instead like try to go start a crypto company. So if we can make the environment in the industry less hostile, less risky, and instead make it more like this is a viable career, this is going to be something that's real. Businesses want to create things using blockchain because they don't think it's a scam. Like, these are tools. That's one way that we can bring more people into the industry, and more people means people that can afford to be less selective.
Mm-hmm.
So that's one. And then two is, if we can build these societal structures that, I got into this because I knew Will, and Will and I knew each other from college. But if I didn't know Will, I never would have even touched a blockchain. Like, that it wouldn't have happened. So how can we build these social networks that are more inclusive, that lift each other up, that give you an opportunity to connect somebody who knows somebody to something? And that's part of the whole idea behind universal consensus, which is recommending female speakers to conferences when they're like, look at our panel of 87 white men, 3 Indian dudes, and token Asian girl. Sorry, Lisa. Like, there's no need for that. There are plenty of really incredible, intelligent women out there, and, people of color out there, and people of different genders out there, and we don't need to like recycle the same speakers every time. So, and then there are a number of other, like the She 256 mentoring program out of Berkeley. Like, they're wonderful, they're amazing. They have been pairing up young women who are in the college program with women who work at, or even mentors who work at various blockchain companies, teaching them, how do you get into blockchain? How do you graduate from college and decide that you're going to go work at a blockchain company? Like, it shouldn't just be people who are risk averse, like dudes that know other dudes. Like, we can grow these networks. We can make this we can make it more accessible. So
I think culture also plays a huge role in that.
Yeah, it really does. Like, women are disincentivized from an early age to go into sciences and go into programming and go into mathematics, and we're just then you have to select for all those things and then select for risk aversity in crypto. Like, all right, we're just making it
The
hard.
stakes are higher, I guess.
Yeah, and I would say that I guess in India, similar to in Southeast Asia or in the Chinese kind of culture growing up, growing up, your parents would tell you, okay, just be an engineer, be a doctor, be a lawyer, because these are safe, stable, like stable bowls, stable rice bowls. And for
Right.
someone of a culture growing up in this kind of culture to say, you know what, I don't want that. I want to do something completely different. I want to build my own bowl. In fact, I don't even want to eat rice in the bowl. I'm going to eat grass from a plate. And that's something very different. And I think there's a culture barrier to that.
I love your rice bowl. I love it. Yeah, there's definitely, I don't know whether this is, like, my mom, bless her, this isn't the first time I've just like tossed the salad bowl of my career and been like, whatever, like, let's do it again. And she, for all of her, like, she started a company. She was a software entrepreneur. Like, I am a software entrepreneur daughter of a software entrepreneur mom. Like, she was like, bowl, you want to use a bowl? Great. Like, I was expecting way less from you. I got lucky. I got mega lucky. I have Will, I have my mom, I have, I went to a good school. I'm extremely lucky, and I want people who are not as lucky as me to have the same chance that I did.
Like, the reason why I brought this up about diversity is that there is this common understanding that it's a very, like, let's use the word cis white male dominated community which transacts in cryptocurrencies. Then we look at countries like Nigeria. I was looking at this graph where 32% of the people over there transact in cryptocurrencies like we do in fiat. How does that explain that? Because, like, these aren't, like, I'm sorry for the lack of a better word, but these aren't very affluent people the way that you see of affluence maybe in the West or in the, like, Chinese region. So how do we explain that? Like, and how can we get this section of diversity become like one of the early adopters and maybe like help get Africa find its feet and become, like, let's say, join the rest of the world in technological advancement?
That's a really interesting question, and I don't know if I've ever considered it from that perspective before, but you're right. Like, people in Argentina use cryptocurrency all the time because their own currency is a little struggling.
Yeah.
And people in, like, we work with this company out of Mexico called Altium, and they are looking for multiple different kinds of options for managing value in a country that doesn't necessarily have sophisticated systems for monetizing different kinds of assets or different kind of land, and so I think that we could do a heck of a better job of, rather than just allowing these populations to be consumers of our applications, cryptocurrencies, processes, but we could also get them to be producers of, there's no reason that, like, this company in Mexico is going to make their own company with a thing on top of our blockchain. And that's part of the purpose of Kadena, of making Pact so user-friendly, so that you don't have to be an expert in, formal verification or, cryptographic hashing, blah, 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 blah. Like, you don't have to be an expert to use our system. And so you're right, we should increase our outreach. We should do better about, rather than just like trying to put our things out there, like proactively say, hey, you should be using this because it will give you the tools to control your own destiny.
Got it.
Another thing that I want to add.
Yeah. Sure.
I just want to add a little bit on Nigeria. The thing about Nigeria is that it's very women friendly, and a lot of the women, they are the household key to all the finances in the house. So that's why most of the transactions are probably made by women, and the government is also quite very inclusive in terms of all the different genders. So maybe that is one of the reasons why we see an uptake in women transacting in crypto, because the culture allows for that.
Got it. So I don't have the numbers on like women in Nigeria transacting in cryptocurrencies, but I have like the statistics, and like these could be like falsified or whatever, is that people in Nigeria in general are using cryptocurrencies. Like, if I have to transact with someone using cryptocurrencies, even with Bitcoin, like, there is that hesitation, right? There's that please God, let that be the right address. All of us go through that. And that is with Bitcoin, which is like the most like used cryptocurrency out there. With things like Ethereum, it becomes a flat no. Like, no, I don't even accept Ethereum. In Nigeria, I was working with someone who was like, okay, I will accept Ethereum because their own fiat currency is not worth much. So they are the ones like who are very open to using those top 5 or top 10 cryptocurrencies. And my key takeaway was it wasn't just people who were like, let's say the risk takers were like, okay, fine, this is this new financial product. Let me buy that. It's also people who are like, we don't have any other options left. How do I buy my stuff? We cannot go back to the barter system. So this is where like countries like Argentina, Nigeria are starting to transact in cryptocurrencies. Yes.
I think another thing is that one of the data that we are probably missing out is that these transactions in developing nations are not by a general population. It's really by the top 5% of the general of the population in these developing nations. So they're not going to be inclusive of the entire economy or entire ecosystem.
Right.
But it gives us a good snapshot of who are the kind of people that will be using cryptocurrencies in these developing nations.
Right. And a final thing is the speed fire round that we have. I'll be giving you a few names, and whatever is the first name that comes up, like in your head, like let us know. The first name is Vitalik Buterin.
Actually, really sweet. Yeah, like just an actual genuine guy who's excited about technology.
Right. He is very sweet.
Yeah.
Elizabeth Stark.
Awesome. She's super cool. She's one of the women in crypto that I'm just like, yeah, you know what? Do your thing. Do your thing, girl.
And we are all like very proud of what she has achieved. So yes. Charlie Lee.
Maybe this is embarrassing. I don't know who that is.
So he's the guy who founded Litecoin. When he heard about Bitcoin, everybody started off like, okay, I will go and mine Bitcoin. He was the guy who was like, I'll make my own Bitcoin. And he founded Litecoin.
All right, well, good for him. Okay.
Yeah, it was like trading at, I guess, thousands of dollars during the 2017 or 18. I think like Lisa might have more like insights to the number side of things, but it was trading at a lot.
It's like an embarrassing oversight for me. I'm pretty poor with names, so like, all right.
Yeah. Think of it as some like, okay, I'll change the thing. Like, let's replace that with somebody who founded Dogecoin. What would you like have a Got it.
Yeah, I'm just like, you know what? Do your thing. Every innovation in the blockchain space is just more opportunity for somebody to make something cool, for us to see what the world can do. Like, I'm down. I'm down.
Right. The last two are left now. Craig Wright.
You know, he's an innovator. I'm gonna go with innovator.
Do your thing.
Do your thing. Like, do your thing, man. Like, if that's what makes you excited, like, go for it.
Right. Last up is an agglomeration of people that we have lovingly known to call the Bitcoin Twitter.
Do your thing. Do your thing, guys. Gals. Other. Do your thing.
With that, we'll be signing off. Thank you, Monica. Thank you, Lisa, for joining us. And that's a wrap on the HackerNoon podcast today. Thank you for listening to us, guys. And we would be seeing you soon.
Thanks.
Bye.
Thank you. Bye-bye. Thank you, Monica.